Hello and welcome back to Trains Up North. Today I'm going to be showing you how I get power to the trains. So there are a couple of ways we can get power to the trains. So we have the traditional pieces where you plug wires into the ends, little connectors on. So you'd have a connector like that, and they simply plug in like that, in positive and negative. Once you put your cables in, you just push it under the track like that. They won't go under every sleeper space, but if you look underneath on the Hornby track, you will see there it is. I don't know whether it's picking it up on camera very well. There is a little arrow, and then if you look on the edge, again, it's difficult to show you on camera. There is two little holes there and one there. So a hole there and there. So this just goes in and it slides in. I think this has got a bit of glue in the hole. So that one there with the B, the shorter one, powers that rail, and the A powers that one. Moving on from that, we have these track pieces produced by Hornby, and what you do with these is get a piece of wire, expose the end, push the tab down, the tab's pushed down, the wire slides in, release the tab, and that's held quite firmly in there. Moving on from that, we have droppers that are soldered onto the bottom of your fish plates. If you don't want to purchase these, you can make your own fairly easy. I will be showing you how I wire my points up. When the point's set like that, trains go down there. So the switch rails are over there, so the trains will run along there. And what happens is the electric will flow down there, and it'll also flow up that rail there. Okay, what it won't do is flow to that top rail there, which if you're working in analog is absolutely fine. You can use that to your advantage. In DCC, we want everything to be live all the time. I model in DCC, so that's what I'm going to be showing you. When you flick it across, the trains will go up there, and the power will flow down that rail, and it'll flow up that rail and up there, and it'll flow down that rail. But what it won't do is flow to that bit in the middle. This is an insulfrog point. We can tell it's insulfrog because it's got a nice lump of black plastic on the frog. So that part of the point there is called the frog, where the two bits meet, and it's insulated, so it's an insulfrog. This, as it is at the moment, relies on a good clean contact there and there. So if you've got paint and dirt and things, it won't conduct the electricity very well, and you can have issues. So how do we get around that? So to ensure that all the track's live, Hornby have come up with these little clips. They look a bit like a really thin, long staple. Just what you do with these is hook them just like so, and then what that does is the electric flows down that rail and it goes through the clip into the other rail, So even when you flip the points over, so normally the electric wouldn't be flowing up there, but what it does, flows along that rail through that clip and then continues, as well as continuing up there. So it just ensures that everything's live all the time. The way I do it is I solder droppers to the rails. So what are droppers? When we're modelling in DCC, you might have heard phrases such as droppers and bus wires. So this cable is thick enough for a bus wire. So what is a bus wire? Bus wire goes from your power supply, so from your controller, and it just goes underneath your layout all the way around. And then what you do is you get droppers, which are normally thinner wires. Twist that, and hopefully you can see the wires are different. Obviously that's got solder on it and that hasn't. So for dropper wires, what I'd normally use is a thinner cable, such as this grey cable. So again, I'll strip this off. As you can see, the dropper wire is a lot thinner. I do use this thicker cable for droppers at the moment, just because I've got tons of it. I've got absolutely tons of it. It was 3 core, so I've got blue, I've got brown, and I've got an earth, which is yellow and green. So what I do, I've got some sections where I've created a reverse loop. I will cover reverse loops later on, but so I don't get confused, it's a really good idea just to keep your wiring simple. So what I do is the blue wire goes towards the back of the layout on the back rail, and the brown one goes towards the front. How you decide to do it is up to you. And then what I'll do is I've got some white wire, I've got some of this blue and green and yellow earth wire. So I'll use the white wire or grey wire and the earth wire on the reverse loop sections, just so I know which one's which. The other things that I do just to help me and provide a bit more information is I've got one of these, get it the right way around, I've got one of these from DCC Concepts. It's an alpha meter. What it does, it tells you how much current's being drawn in amps or milliamps and the voltage that's going through. So on the back, wiring, really easy. It's got input and it's got output. So your bus wire, put your bus wire from your controller and you put it in, and there's 2 screw terminals on these little green blocks and 2 little terminals underneath. So what you do is, I'll use a wire that I've just stripped down, put your wire in to the block like that, and then just tighten it up using that screw. Once you've done positive and your negative from your controller, you just simply click that in to your input. So coming out on the other side, what you do is you get another one, which I have here, and you just plug that in on the other side like that, and that one would go to the bus. Other little tips for bus wire is your bus wire doesn't need to join up. So what you don't do with it is, if that was your bus wire going all the way underneath at the end, you wouldn't put a connector joining the start and the end up. You just leave it like that. And then when you get your bus wire, the other thing that you can do, which is a good idea because of some electric interference things that I don't fully understand because I'm not an electrician, you just twist them like that, you get better results. The reason you don't join it into a loop, into a ring, is apparently, again, I'm not an electrician. If there's someone out there that understands this a lot better than me, if you want to put the reason why and a better explanation than me in the comments, feel free. So apparently what happens is the controller, if you had your controller here and it sent a signal down the wires, it'd send it both ways. If they were joined up, it could end up hitting the train at slightly different times, and you're talking about fractions of a fraction of a second, but with electronics that can make all the difference. So to install the droppers, what you need is a decent soldering iron. This is fairly cheap. I got it off a well-known online retailer, and it's got a dial on it so I can adjust the temperature. So because I'm using thick wire, I set it to quite high, and what I'm going to do is, I'll do this off camera just because it's easier, but I'm just going to cut away at the back of some of the sleepers, just so I'm going to cut away at the back of the sleepers just to expose the metal of the rail underneath. So then I need to think about which way this is going to go. Get me wire that I've stripped. So that's going to be, the point's going to go this way round, so that rail there is going to be at the back of the layout. That one's going to be at the front. That one's going to be at the back, and that one's going to be at the front. So I've got front, back, front, back. So back, front, which is that one, continuing up there. That one's going to be back, continuing down there, and that one's going to be front. So blue to the back on my layout. So turn it over, it ends up being at the front once I've flipped it over because it's reversed. Get a little file, and what I do is just run over underneath the track with the file just to give it a bit of texture. I find this works for me. Some people might not do this. So once I'm happy with that, just make sure that it's clean. I'm going to get this solder. So this is lead-free solder. I don't use any flux because this solder contains flux in it. So my soldering iron's at 480 degrees. So I'm just putting a bit of heat in, and I'm just, so the other thing you might hear with electrics is tinning the wires. So I'm going to strip a little bit more off because what this wire is going to do is just cover both sides. These wire strippers are great. I'll let you know what they are in the description below. So you just put the wire in, and then easy as that. Twist the wire together. Put in a little bit of heat from the soldering iron, and There we go. As you can see, the wire is nicely coated. When you're soldering, it might sound a bit daft. I'm not teaching you to suck eggs. Things do get hot. So what you want to do is start off and practice when you're soldering on straight track, because straight track's easier than point work. You've got a little bit more room to work, especially if you've put the sleepers at a more realistic spacing. You try and do that with points and you encounter all sorts of issues. So then what I'll do, once I've soldered the droppers to the track, zoom out. So once I've soldered the droppers to the track, just get this cheap and cheerful tester. What this will do is it'll bleep when there's electric flowing. So when the electric can flow, it'll bleep. So if I put it on that rail and the outside rail, nothing happens. Hopefully when I put it on that rail, yes it does, it bleeps. And again on that. So what I'll do is test that one up there and that one, and then I'll switch and do the back rails. And just so I know I've got it right, the track's going that way around, so the blue is the back. Oh dear, we've got an issue. So the issue I've got there is I've soldered them the wrong way around. Not a huge issue. What I'll do is I'll use that set of points somewhere else. We're going to do a set of points, and these are going to be electrofrog points. So these are Pico electrofrog points, and the reason they're called electrofrog is quite simply because the frog is made out of metal, so it conducts electric. So this poses us with a problem, because if that's your positive and that's your negative rail, so that'd be negative and that'd be positive, and that'd be negative, but they join up there. So how we get around that is when we join them together, we use a plastic fish plate. So normally with your track, what you'd use is metal fish plate, such as that. So simple metal fish plate. The reason we use metal ones is it keeps the track in place, and it also conducts electric from one section of track to the next. If you put droppers on every single piece of track, it doesn't matter if they don't fit quite perfect or if they get dirty. And then if I can get the camera to focus, that's a plastic one, and it just has a little lug on the top there. Again, the camera's struggling to pick that up. Hopefully you can see that. So what we do is we put a plastic insulating fish plate just on both sides of that. Then underneath there is a metal wire that comes off, that goes to the frog, and when we do our point motor, what we'd do is that piece of wire that comes off the frog, those plastic insulated fish plates. So we'll solder a wire to that. That'll be a grey wire for my layout, and then we'll solder the blue and the brown wires to the points as we would normally. One thing that I will not mention with these is they have there, if you can see it, and there, a little wire that just bridges what we do with that, because we don't need it for DCC and the way I'm wiring my points up. Is we just cut through it. So it will cut with a Stanley knife. We'll cut it off, and then we just bend it. Bend the wire with the tip of the blade, just so it's never gonna bridge, because that could cause us with a short circuit. What we're going to do, just cut the plastic away. So this is the same now for both types of points, whether it's insulfrog or electrofrog. We'll just move them, brush them to one side, get a little file, and then with the file we're just going to rough up the underneath. I have read and watched videos where people say this is not necessary and that this can actually be worse because it lets dirt and things get into the grooves on the track. It works for me. Soldering iron, it's at 480. And we're just putting a small blob of solder onto the track. I do have different solders for different things. The Hornby and the Pico track seem to like different solder. Don't want to touch that piece of wire because it's going to be hot, and on this instance I'm going to wire it towards the centre. I did, when I first started many moons ago, when I was a teenager, I did try and solder droppers with a 15-watt soldering iron that I got, I think it was from Maplin's. It was a cheap 15-watt soldering iron, and needless to say, it didn't work. It didn't produce enough heat. So, a number of years later, I got this one, the soldering station with the temperature dial, and it works. And it works a treat. So what I'm going to do is just give them a little tug, and they seem solid enough. So now they're on, we're going to flip the track over, and using a little tester, we're just going to check that the electric flows where it's meant to. So putting the probes, touching the probes together, it bleeps. Touch that one and that one. The electric should flow. We'll move it along to the end of the points, and I touch the V in the middle where the frog is, and touch the outside rail. Nothing happens. Fantastic. And then I touch the other rail, and nothing happens, which is exactly what I want. However, if I touch the frog, I touch that bit and that bit, it works. So I'll touch what's going to be the front rail, that, and that bleeps. And then what I'm going to do is just put my probe on the brown wire, just to make sure that it does flow through the brown wire. And then I'm going to switch. I'm going to do the same for the blue, and we know that works, so we're happy with that. So what I'm going to do now is I'm just going to solder the grey wire to that. So I've soldered that. What I'm going to do is a piece of heat shrink just over the end. Slide the heat shrink over the soldered joint, and then just run the heat shrink run the soldering iron over the heat shrink. You could use a hairdryer to do this. So what happens, heat shrink, as the name suggests, it shrinks under heat. What I have got, and I highly recommend, is from a label maker. I've got heat shrink that I can print on. So this is for the Heritage Points Hotel 1 Alpha. So code that I use, PTS for points, Hotel 1 Alpha, Heritage Points 1A. This isn't the right point, but it is for that Heritage Point. So if this was the Heritage Point that I needed, that I wanted, once underneath, I'd just put that on and then just heat shrink that. And what I'd probably do is put all the wires together so that underneath, once they're through, I know which points, which wires that are for that piece of track. So insulfrog points, exactly the same there. You don't have that. You don't have to worry about putting insulated fish plates on. So that's how I wire up my points. I use soldered droppers on every piece of track on the layout. I don't want this video to go on for much longer, so in the next part I'll show you how I connect the droppers to the bus wire and install the points. I'd like to say thank you for watching. Don't forget to comment, share, like and subscribe, and until next time, goodbye.